she's been waiting.
She's been waiting half an hour.
I hope the microphone's on.
Yeah, it is on. Thank you.
Please just catch these.
Yeah, I hope you didn't forget. Nikita, we're going to find the answer. Maybe you already been screaming at us and we haven't been paying attention. Gavin.
Okay. So it's also a square root of x in the denominator, and then a 1 on top. And
Okay.
And then that equals 0.
Oh, very good. So were you working over this during lunch?
I
Okay.
thought about it.
Okay. All right. What about this one, Ellie? What do you think that one is? Hmm?
What?
I didn't hear any. What do you think it is? I don't expect you to do it. I just want to know, just you looking at it, analyzing it, what do you think the answer is?
My guess would be 1.
What? I still didn't hear you.
1.
1. Okay. I hear that answer a lot. Why do you think it's 1?
I mean, I think it's 1 because as x approaches infinity, what we're adding to 1 gets closer to 0,
Yeah.
but then 1 to any exponent that approaches infinity is just 1.
Okay. What do you think?
So it never actually gets to 0. Like, it never does. So like it's 1 point, like 0, 0, 0, but it's a little bit, and put that to infinity. So it has to eventually infinity.
So you think the answer is infinity?
Yeah.
Okay. What about you?
I was thinking infinity as well, because you have 1 to something that's slightly above 1 to an infinite number.
Okay, so we have 2 people that think it's infinity and 1 person that thinks it's 1, right? And Brady, what do you think?
I was thinking infinity as well.
I think
Okay.
it's 2.
You think it's 2? Why do you think it's 2?
Like 1 point something will eventually get to 2.
And then you just stop.
I mean.
What about you?
point.
What about you, Hannah?
I mean, Gavin has a point, but I kind of agree with what Ellie said with the 1.
Okay. So you're divided between 2 and 1, so 1.5?
No, I'm not divided between 2 and 1. I thought that was funny. So I'm thinking 1 or I don't know.
Okay. But you would agree both. There might say validity.
I agree with everyone.
Okay, Ryan, what about you?
I agree with whoever's right.
Who's ever right?
Same.
Aaron? Okay. I'm going to go to the machine.
What's the machine say?
I don't know. Let's see. Let's make sure I got that correct. That looks right, doesn't it? Right?
Oh no, this is stressful.
That's 10,000?
Yeah. You're not even gonna be able to differentiate one. Oh, that's the X one. That's okay.
What?
No, you're good.
Okay. It's something.
It's E.
Oh.
Yeah.
Wow. That's good.
So I was the closest.
I mean, you're not wrong.
Well, there's 2. Looks like it's E. Let's see. I'm going to show you the proof of E. You're going to need to know this method. So what I'm going to do, and I'm going to start way over here, I'm going to let y equal the limit as x goes to infinity of 1 plus 1 over x to the x. And I'm going to take the natural log of both sides. Since this is a continuous function as you go to positive infinity, I can rewrite this as the limit as x goes to infinity of the natural log of 1 plus 1 over x to the x. That gives me the natural log of y equals the limit as x goes to infinity of x times the natural log of 1 plus 1 over x. So I'll bring this up here. So I'm going to write this as the natural log of y is equal to the limit as x goes to infinity of the natural log of 1 plus 1 over x over 1 over x. And save myself room, I'm going to take the limit of this. The limit of this, of the numerator, this will go to 0, correct? Would everybody agree? And I'll have 1 plus 0, correct? And so I'll have the natural log of 1, correct? Which is what? The numerator is going to 0, correct? And if I take the limit of the bottom, it also is going to 0, correct? Would you agree with that? So I can apply L'Hopital's rule. Right? Are you guys okay that when I multiply by x, I can divide by its reciprocal? Right? You're okay with that? All right. So now what I'm going to do is I'm going to take the natural log of y, and it's going to be the limit as x approaches infinity. I'm going to do L'Hopital's rule, and I'm going to get, where did I write that? Well, on the bottom, I'm going to have 1 plus 1 over x, and on the top, I'm going to have negative 1 over x squared. That's the derivative of the natural log, correct? Right?
Yeah.
Over the derivative of this, which is a negative 1 over x squared.
Don't the 1 over x squared or the negative ones cancel out?
Yeah, they do, don't they? Okay. So this and this cancel out, right? And that's going to give me the limit as x goes to infinity of 1 over 1 plus 1 over x. Pardon? Slide it this way. What's the limit of this? One. So that means the natural log of y equals 1. Well, that must mean that y is equal to e to the first power. Well, what is y? Y is this limit. So this has to be equal to e. And that's the definition of e. This is actually the definition of e. Isn't that cool?
So some dude just one day just made that problem.
Euler did.
So he just like, how many other problems did he test before that to find? Like, was he trying to find E, or did he just like stumble upon it?
Well, they kind of knew about e because if you'd look at compound interest, and this is really a compound interest problem. You start with $1.
Oh, that's like per.
Yeah,
I didn't realize that.
yeah. And so if you say, okay, what if I compound all continually forever? Is there a limit to the max that I can make? And there is. Then that limit is always around $2.72 for every dollar. And lo and behold, because of the use of money, and so this is my favorite equation. Now I'm digressing. We actually proved this in class also. You guys know that, right? That's my favorite equation.
No idea what it means.
Hi, how are you?
I'm subbing, but it said she takes her break at the beginning of the hour.
Okay, who are you subbing for? You know she's not in here? This is a different class?
Is it?
Yeah.
It said geometry.
No, this is a calculus class. Okay.
Period 4 though.
Yeah, but yeah, period 4, there's a different class in here. Okay, but thank you.
They have the rate.
You know, if you're interested in watching yourself, you can go to my YouTube site.
Do what?
Nothing. Just wasn't as funny as I thought it was going to be.
She's gonna like not
I
realize
thought
she's
like
supposed to
she
be
was
here next
someone
hour
coming.
now.
I thought she was someone just coming
So-
to watch her class. I was like, I never knew her before.
Have I told you guys about this equation? This is called Euler's equation. It's the greatest equation in mathematics. I think it is. It's got all the important numbers in math, 0, 1, I, pi, and e. It represents arithmetic. It represents exponents. It represents mathematical analysis, and represents geometry, all in that equation.
Solve that.
What?
How long does it take to solve that?
The proof for this?
Yeah.
The proof is coming in,
Oh, we do it?
yeah, we do it in here.
Oh.
That's pretty cool.
What's it called?
When we get to talking about series, we do it, okay? An infinite series. There's fireworks and lightning and loud music. Sometimes dancing, depends on the day.
Alright.
All right, so here's another one. And we're going to start this one the same way. It's the same technique. Oh, what do you think this one is?
Probably similar.
Because you're headed to 0, right? So where is sine headed? Sine headed
It's a 0.
to 0, right?
Right.
From the right, it's headed, is it? But then you must have positive fractional exponents, right? So we're going to start out the same way. I'm going to assign y to be that limit. And then because this is an exponent, you have to take the natural log of both sides. And I'm going to jump right away to this, because this is continuous when you're greater than 0. And I think you're okay with that, me shortening that up. Am I right on that? Okay, so now I'm going to write this as a natural log of y is equal to limit. And this is a very common technique, because I need this. Okay, now to apply L'Hopital's rule, I have to look both the numerator and the denominator individually, okay? So, and Brady brought up a great question, and if you remember, I said this is the graph of the natural log. Remember we were talking about where it's headed if it's going to infinity, and you thought perhaps negative, and I said, oh, well, let's take a look at it. And here we're approaching 0, and here we're approaching positive infinity. Remember that? And I drew this graph. This is going to be, I'm glad you brought that up because it's very helpful here. Okay? So if I look at the numerator, as I head to 0 from the right, sine is headed where? To what? 0. So if I'm headed to 0, where's natural log headed towards? Negative infinity, correct? Right? So, right, I just showed you the graph? Okay. Were you paying attention? Or okay. So, negative infinity. Well, you know, we all go in our places, and there are multiple times during this class you could say, Kruger, were you paying attention? And no, I was somewhere else. And I was the person teaching at the time. Okay.
See, Rush just doesn't get that sometimes.
Okay. What?
Rush just doesn't get that sometimes.
Yeah, well, I understand it totally. So, as on this one, where is this one headed as you're going to 0 from the right? Positive infinity. So I can apply L'Hopital's rule, correct? Okay, so let's do that. So I'm going to write the natural log of y is equal to the limit as x approaches 0 from the right. So what is the derivative of the natural log of sine? What's on the bottom? Sine. What's on top?
Cosine?
Cosine. What do we call that? Cotangent. Excuse me. Now,
Oh, that's the derivative.
what is this going to be?
X to the negative 2.
What?
X to the negative 2, so 1 over x squared.
You're close. You're really close. You're really close.
1/2 x squared.
No, I think it should be a negative 1 over x squared.
Negative 1 over x squared.
Right? Would you agree? And so this can be rewritten as the limit as x goes to 0 from the right of a negative x squared over tangent. Because tangent is the reciprocal of cotangent. Thank you. So where is this headed? 0. Where is this headed? 0. So I could do it again, can't I? So now I'm going to get that's equal to the limit as x 0 to the right of a negative 2x over, what's the derivative of tangent? Secant squared. So where is this headed? 0. Where is this headed?
0.
Uh-uh.
Infinity.
Nope.
Yeah, it doesn't matter.
What? 1. Because it's secant, right, is the reciprocal of cosine, correct? And the cosine of 0 is 1, and the reciprocal of 1 is 1. So this is going to be 0, correct? So that means the natural log of y has to equal 0. Well, that means that y is going to equal e to the 0. So this limit is 1.
everything where you take the natural log is gonna be something to do with E.
Correct.
So right with the zero
What?
being where the X is. I thought it was gonna be 1 because it's approaching 0.
Oh, you thought it was going to be 1 anyway. Was that your guess? That was 1? Oh, okay. And why did you think it was 1?
Because of the exponent, as it's approaching 0,
Yeah.
it's gonna approach 1.
Oh, because you have an exponent that is approaching 0, and anything to the 0 would be 1. Yeah, it kind of makes sense. 0 to the 0, you can't say. But it's not going to be 0. But you see what you're saying? And that other one's getting so close to 0. Yeah, I could see. Yeah, that's a decent argument. Yeah. Okay. Better than the argument about E.
Yeah, I know it's the closest. I agree.
Well, it is. You know what? You know what I said? I said 1 on this one. But I could see the people's argument for infinity. That makes sense to me also. It does not seem apparent to me. It's 2.718.
Yeah, like, why that?
Yeah, but it's a very nice proof, and you guys are at the place where a lot of it is kind of making sense, right? Okay, so we're going to do this next one. Any guesses?
Okay.
I like this part best,
I
the
bet
guess.
it's E to the third.
You think it's E the third?
Yeah.
Yeah, I like E and I like the number 3. Yeah, okay. It wouldn't be a logical answer, but it'd be an emotional answer. What do you think? Anybody?
42.
I'm gonna go with E, 1 over E.
Zero.
0?
0.
Okay, so let's start. I'm going to write this as the limit as x approaches 1 from the right, and I got x minus 1 minus the natural log of x all over the natural log of x times x minus 1. So I got a common denominator. That's all I did. And as it approaches 1 from the right, what is that limit?
0.
0. Okay. As I approach 1 from the right down here, what's it approaching?
0. Yeah.
It's 1.
Well, 0 is
0 also.
Yeah, 0.
Correct?
Oh, yeah,
Yeah.
yeah.
We okay on that?
Yeah.
Okay. So I'm applying L'Hopital's rule. And I get 1 minus 0 minus 1 over x on top. Okay. And on the bottom, I got to do the product rule. So I have the natural log of x times this derivative, which is what? 1 plus x minus 1 times this derivative, which is what? 1 over x. And that gives me gives me on top,
With 0 on top.
get 1 minus x here, and down here I get the natural log of x plus 1 minus 1 over x, correct? So if I take the limit of that,
Still 0 again. on both.
is it still 0?
Yeah.
So I can take it again?
Wait, we did
That's equals each other. You just simplified it. You didn't actually take it.
Oh.
Yeah, I just simplified it. So what I'm going to do, I'm going to do one step before that. I'm going to take and write this as the limit as x approaches 1 from the right this on top is x minus 1 over x over the natural log of x plus 1 minus 1 over x. And I can say that is the same as the limit as x approaches 1 from the right of x minus 1 over x ln of x plus x minus 1. So what I did is I brought this x down here and multiplied it through. Does everybody see that? Okay. And so the limit of this is still 0, and the limit of this is still 0. Correct?
Wait, would it be more beneficial? So I'm just gonna to take like you have a 1 minus x here and 1 minus x here. So could you like factor in 1 minus x by like putting this over 1 minus x and then just cross them out?
Perhaps.
Okay, I never just continue.
No. I'm not saying, but I've already written this, I only got so much space.
Yeah.
Okay. So they both head to 0, right? So I can take the derivative, and luckily this is our one last time. The derivative of this is what? 1 over.
Could you move it over?
And I'm going to have x times 1 over x, because I got to do the product rule, plus the natural log of x, plus 1, and then this minus 1 goes to 0. Correct? Right? And this x, 1 over x, is going to become 1 plus the natural log of x plus 1. Right? And now we're headed from 1 to the right. What do I get as an answer?
1/2.
1/2.
So 1 over e wasn't that far off.
No. 1 over e was probably the closest of the guesses. Did you say 1 over e?
Yeah.
Okay.
It's like 1 over 2.7.
Just like 2 was close to 2.71.